VGA, look at these 15 pins. Each carries a fragment of your image. Analog, trembling, hoping to survive the journey. What happens when the signal dies on the way? Video graphics array. That chunky blue plug from old monitors and projectors. Here's what nobody mentions. VGA doesn't send a digital image. It sends a voltage curve, converted to analog by your card, then back again by the monitor. Twice. Every conversion bleeds sharpness. That blurry slide you blamed on your laptop? That's physics, not a fault. Millions of projectors still run on VGA. No driver install. Plug in, it works. For sharpness, VGA doesn't deliver. VGA versus HDMI. HDMI sends a digital signal. What goes in comes out. With VGA, information is lost. Same room, same file. Different image. The analog signal is dead. What that connector can't do is where the next port begins. Audio jack, one hole, 3.5 millimeters. And somehow someone decided that was enough. Audio out and audio in at the same time. How does one hole carry two conversations? The 3.5 millimeter audio jack. The port everyone ignores until it's gone. Here's the fix nobody talks about. Older computers had two jacks because TRS was a one-way street. TRRS changed that. 4 rings, both directions, one port. The headset with a built-in mic? That's the fix. So quiet nobody noticed there had been a problem. Zero latency, no compression, no pairing ritual. It never drops, never lags. Bluetooth has closed the gap for casual listening. The jack matters when failure has a cost. Bluetooth compresses, adds latency, disconnects mid-sentence. The jack does none of that. But what if the signal isn't audio? It's data. You need something everywhere, and almost nobody understands it. Ethernet. Your router sends a signal through the air. Your laptop catches it, interprets it, converts it. Something gets lost every time, and you've never seen the number. Ethernet is the wired connection. Cable in, data flows through. Here's the number nobody shows you. Your internet plan caps at gigabit. Most home Wi-Fi doesn't consistently deliver that. Ethernet does. You're paying for that speed. Ethernet is using it. Competitive gamers hardwire because 10 milliseconds versus 40 milliseconds ping decides rounds. Streamers use it so broadcasts don't stutter. For email and browsing, Wi-Fi is fine. Ethernet earns its place when failure has a cost. Ethernet is boring and bulletproof. What about the connector linking every device? That one was chaos before someone cleaned it up. USB, the 1990s. Printer, keyboard, mouse, camera, scanner, each a different shape, cable, driver. There was a drawer. Everyone had the drawer. Then someone said, one port for everything. Universal serial bus. Not the flashiest, the most important. Here's the twist. Megabits and megabytes are not the same. 1 megabyte is 8 megabits. USB 3.0 moves 2.5 gigabytes per second in practice, not 20 gigabits. That gap explains a lot of disappointment. USB 3.0 is where most people live. USB 4 hits 40 gigabits. Not every USB-C port is equal. Same shape, completely different specs underneath. Buy the wrong cable, and you've already capped the connection. Type A went in wrong every time. Type C works first try. USB solved the connector problem, not the display problem. Screens need a dedicated standard, one now in every living room on the planet. HDMI, one cable. Video and audio together. How did one port end up in every TV, every console, every conference room on Earth? High-definition multimedia interface. The port that quietly won the living room. Here's the catch. HDMI 1.4 brought 4K at 30 frames per second. Everything moving on screen looks like Vaseline on the lens. Not because the TV is bad, because 30 frames can't sustain motion. HDMI 2.0 fixed it. 4K at 60 Hz. Same label, completely different result. Most people never knew there was a difference. They just knew something looked wrong. Nearly every TV, monitor, and console ships with HDMI. For home cinema, No argument needed. One hard limit. One port, one screen. HDMI is in every TV. DisplayPort is on almost none. For the couch, HDMI. For the desk, that's a different question entirely. DisplayPort. Same shape as HDMI, one corner clipped at an angle. That corner looks like nothing. It changes everything. What does it unlock that HDMI fundamentally can't? DisplayPort. One angled edge. One completely different philosophy. Where HDMI was designed for living rooms, DisplayPort was designed for desks. Daisy chaining, monitors chained off each other. A full row from a single port. DisplayPort monitors aren't just receivers. They're nodes, passing the signal forward. HDMI sends to a screen. DisplayPort builds a chain. Programmers, editors, traders, anyone whose work spans multiple screens. DP 1.4 handles 8K at 60 Hz. The architecture is the point. DisplayPort is almost never on TVs. HDMI runs one screen. DisplayPort runs several. Which you need depends on where you're sitting. What if one connector handled display, data, and power simultaneously? That's what USB-C promises. Whether it delivers is a completely different story. USB-C, 2 laptops, identical oval ports. One, 20 watts, no video. The other, 100 watts, 40 gigabits, drives a monitor, same connector. Why? USB-C is not a speed rating, not a standard. It is a shape, and that distinction is costing people real money. The connector does nothing. The cable does. Buy a USB 2.0 cable, plug it into a Thunderbolt 4 port. You've paid for a motorway and built a farm track. Right cable, right port. Data, power, video. One cable instead of 4. Skip the spec sheet and you buy disappointment. USB-C, USB 2.0 versus USB-C, Thunderbolt 4, same oval. One, 480 megabits, 20 watts, no video. The other, 40 gigabits, 100 watts, 2 4K monitors. CAN isn't guaranteed. One more standard separates promise from delivery. The one marked with a lightning bolt. Thunderbolt. Same oval port. Same cable shape. One tiny engraving changes the entire capability of the machine. What's behind that symbol? Thunderbolt is Intel's certified protocol on the USB-C connector. The only tell, a lightning bolt etched next to the port. Before Thunderbolt 3, a thin laptop was a thin laptop. Serious rendering, 2 displays. That required a tower. Thunderbolt 3 broke that rule. 40 gigabits. An external GPU in a MacBook Air delivering desktop-class performance. The machine in your bag and the machine on your desk could be the same machine. That's a category change. TB3, 40 gigabits, 2 4K monitors. TB4, same speed, stricter certification. TB5, 120 gigabits, 240 watts, 3 4K screens. Thunderbolt costs more. If you don't run multi-screen workloads or external GPU, good USB-C is enough. Thunderbolt delivers what it promises. Generic USB-C depends on which cable you grabbed.